Hello everyone, and welcome back to the ccubed channel. This is another tier 1 video, so this is going to be for those who are doing the GCSE Maths Foundation tier, and those who wish to be starting from the basics. So today we're going to be continuing on with quadratics, and in the last video we were doing expanding quadratic expressions. Today we're going to be factorizing quadratic expressions, so we're going to be seeing forms such as this. We're basically going to be essentially doing the reverse of what we've done in the last video. So, very quickly, we're just going to do a quick recap of factorization, what it is. So, we've said several videos ago now, if you have forgotten about this, I would recommend to go back and check on that. You can see it through the Algebra playlist, which is on the channel, or you could just look through the channel itself. But I covered this in a different video for linear expressions such as these two here. So we said that factorization is the reverse of expansion. So if you want to factorize an expression and you're going from one form, such as this one here, into another form, which is one with brackets on it, for example, So, just very quickly, we're gonna just look over these here, just to, refresh ourselves on factorization. So we have 3x plus 6. Alright, now remember that what I said with this is that you always look for the common factor here between the terms. So in this situation, we can see that we have 3x plus 6. Both 3 and 6 are multiples of 3, so we can actually take the 3 out, and we are left with x plus 2. Now remember, when we take the 3 out, we are dividing each term individually by that factor. So for example, we see 3 is a common term here, so we put 3 out, so then we did 3x divided by 3, which gives us just x on its own. And then we have 6 divided by 3, which gives us 2 on its own, and then that's what goes in the bracket. So that's the process of linear factorization. So it's pretty much as simple as that. In the next situation here, we can say again, in this case, common factor here is z. So we take the z out, and then we have 4 plus 5y. So again, you can see here that you dividing z through by everything here. So 4z but divided by z is just 4, and then 5zy divided by z is 5y, and then the z goes on the outside. Simple as that. Now this down here, this is a quadratic, as we've seen in the previous video and probably the video before where I was talking about what a quadratic is. We said it's a polynomial, is something called a polynomial, which is a string. It's like it's a list of terms with descending powers or ascending powers. So what I mean is we have something, in this case we would have a squared, then you have like an x squared, then an x, and then a constant, which in this case the constant is 0, which is why we don't write it. So in a situation like this, because this is quite an easy one to do, we can take the common factor here, which is just x, and then we can do the same thing as what's up here with these two. So we do x times x plus 1, because we just divide x through by both of them here. So this one's not too bad, but we're gonna go into the next bit now, where we're talking about terms that have all 3 instead of just 2 like this. And we cannot use this kind of method anymore. We have to use a new type of method now. So let's go on, and we're going to be talking about factorizing quadratic expressions now. So the aim for factorizing quadratic expressions is that we go from a quadratic form, such as this here on the left, into an x plus a times x plus b form, such as on the right. Now this one here is already done. It's already gone. Both of these are equivalent, so this is already being done. But we're gonna go ahead and go through the steps, slowly, to see what we can actually do here. So we have to find. The basic premise with factorizing quadratics is we need to find But we need to get it in this form here, where a and b are different numbers, such that if you expand them out, you'll go back to the full form, the polynomial form. So basically, you have to find something that can factorize into two factors like this, and if you expand that out, like we've done in the previous video, we learned how to expand quadratics, you should get back into this again. So, as I've said, this already worked, this is all done, but we're going to go ahead and just go see ourselves how to do this. Now, there are several methods, but the best way that I was taught it when I studied this, and the best way that, the way that I use it now, is we look at the numbers here. So now in this video and the next one, we'll only be, for tier 1, which is GCSE Foundation, we only deal with x squared on its own. Going into tier 2, which will be soon, which is the higher tier, we'll be dealing with coefficients, which is just a number in front of the x squared. We'll have some extra terms there to worry about, but for now, we're going to start basic, we're going to start easy. So, we need to look at, we have a 5 here and a 6 here, so we need to find two numbers, right, that will, well actually hold on, before I even say that, let's just quickly write it out here. So, obviously it's going to be in this form here. We're going to go from that to that, alright? So that's what the form will be. And so now, we need two numbers that can add to 5x, and two numbers that can multiply to 6. So let's just quickly write that out. That's a bad plus, but yeah. Don't worry about that. So, two numbers that add to 5, and two numbers that multiply to 6. Alright? And we'll see why we even do this in the first place, but first we need to get the numbers. So, this is basically kind of a trial and error type thing, kind of. I mean, sometimes it's very obvious to see it, other times it might take a bit of time just messing around with the combinations, but usually you'll get it. At a later point in tier 2, when we look into using the quadratic expression, the quadratic formula, this procedure will pretty much not be needed anymore. You can kind of just jump straight to the solution, but sometimes it's good to do this as well for other things, that we'll look into. But so, two numbers that add to 5, two numbers that multiply to 6. So if you haven't thought of it, if you haven't realized it by now, it is quite simply 2 and 3. Now, I mean, that is literally what we have on the right side here, but we're just seeing where this comes from. So we can see here that 2 plus 3 is certainly 5, and 2 times 3 is most definitely 6. So what we do now is we just quite simply put them in here. And it doesn't matter what order it's in. 3 could be first and then 2 could be second. It really doesn't matter. I usually like to do them in ascending order, but again, it really doesn't matter. Seriously, honestly. So that is literally all we get. There we go, done. We've now factorized the expression. And if we expand this out, then we'll see why we need to do this here. So let's just quickly expand this out. If you don't remember how to expand, I would recommend checking out the previous video where we went over this, how to expand quadratics. So that's something you can look into there. So we're just expanding them out here. And you can see here, so we've done that times that, that times that, oh whoops, we did that times that, and that times that. So we're now getting this string here, right? And basically what happened is, you can see in the middle here, this term here, these two here, is basically corresponds to that part there, right? Where the two numbers that add to 5, and that's, if you actually simplify that out, you would get 5x. And then the last one here, 6, is a result of 2 times 3, which is this. So you can see how they relate. You can see why we do this kind of method here to get the quadratic itself, like to get the factorized form. And that is quite simply because if you expand this out, you will get the individual parts, which tells you what the two numbers are that make up the quadratic. So usually, if you don't know what I mean, I guess it's good to check, I suppose, to see if it will make sense. But when you factorize this out, it's always good to expand it again, obviously. Okay, so that's done. Let's take a look at the general form now. So this, now this might be a bit, this might be a bit overwhelming, but quite simply, this is just a general equation where a and b can be any numbers. Now, we've seen this form here already, and that is like this. So in this situation, a is 3 and b is 2. So if we set that to that, if we set a as 3 and b is 2, then we'd have 3 plus 2 x plus 3 times 2. And that is quite simply just exactly the same as that. So that's just a general form, and that is always, this here is always equal to x plus a times x plus b. So always two numbers that multiply to give you the last one and add to give you the second term. That's the general form, and that's the general procedure with any kind of quadratic expansion, honestly. That is when you just have x squared on its own. So let's do some examples now. So let's start with the top one here. X squared minus 6x plus 9. Okay, so we need two numbers that add to minus 6 and two numbers that multiply to 9. So in this case we can see, okay, well, again, this is a bit of a trial and error type thing, but you have to kind of experiment around a little. So we have 3 is a good contender here. So I mean, well, now the problem is we have a minus sign here as well, by the way, so we have to account for that negative. We have to kind of work around with the signs here. So in this situation, minus 3 for both of them is actually the solution, and the reason is because minus 3 plus minus 3 is minus 6. Ooh, that's too big. And again, minus 3 times minus 3 is 9. Right? So in this situation we can see that this top here corresponds to that, and the bottom here corresponds to that. So in the end we could just say x minus 3 times x minus 3. And if you want to, you could take it a step further and just say this is x minus 3 squared. You could just take it to that step, but usually you don't really have to worry about that. So that's that one. For the next one, we have, again, same situation, two terms, two numbers that will give you minus 3 if you add them, and minus 10 if you multiply them. Now in this situation, because I've already done it in my head, well, I've already done them before recording this, so we'll go through kind of quickly, but what we have here is we have minus 5 and 2. So the reason for that is because minus 5 plus 2 gives you minus 3, right? So that'll be minus 5 and plus 2. And again, with the last term there, minus 5 times plus 2 is minus 10. So these two multiplied together at the end here will give you minus 10. So that's this one done. For the last one, x squared plus 10x plus 24. In this situation, the two numbers are 6 and 4. And the reason is, if you multiply, if you add 6 with 4, so 6 plus 4 is 10, and 6 times 4 is 24. So that's what we have it like that. And that is literally all there is really to it. I mean, there's nothing really, there's nothing much on this. It's just a matter of practice, really. Just keep making up stuff. As long as you have two factors here that can add together and can multiply together, then you can pretty much have a huge range of different expressions to factorize. So I would recommend to just keep practicing on this, just keep looking over this kind of thing, and the more you do it, the easier it'll be, really. That's all there really is to it. Okay, so one more example before we're done is the quadratic expression here. So x squared minus 9. Okay, so we've come across something like this before in the last video. We came across something called the difference of two squares. And remember that what I said there is that you have x plus a times x minus a will give you just simply x squared minus a squared. That's what we've said in the previous video. So if you don't remember that, go back to the last video, expanding quadratic expressions, and then you can refresh yourself on that. Now, if you want to go backwards on this, it's quite simply a matter of just recognizing when you have to use it. And it's very simply just when both terms are square numbers and there's a minus in the middle. So what I mean is x squared is a square number because it's just x times x, and 9 is a square number because it's 3 times 3. So in this situation, it is quite simply, you could just go straight to saying that the end result is x plus 3, x minus 3. Just like that. So if you want to take the long way in doing that, then I suppose you can. So in this situation, you can see you have 3 plus minus 3, which gives you 0, and obviously 3 times minus 3, which gives you minus 9. So it was basically two numbers that give you 0 in the middle, which is why there's no x term on its own, and then you get minus 9, which is that one there. So that would correspond to, let's just write down all of it, x squared plus 0 there we go, x minus 9. So that's literally what that is. I mean, that is the same as this. There's nothing, it's just a different way of writing it. We just got rid of the 0x because we don't need that, literally. So you could kind of see it like that as well. Two numbers that give you 0 when you add them, and two numbers that multiply to give you 9. But I would recommend just quite simply, in this kind of case, just simply jump straight to this. You don't need to go through this effort because the numbers would be the same. One is just positive, one's just negative, always. So, that's simply the case. Okay, so that is all I had to say on factorizing quadratic expressions. Thank you guys so much for watching this video. If you have any questions or need any further elaboration, feel free to just comment and just post any comment, ask questions, literally just, I encourage more questions the better, honestly, so you can learn better that way. So thank you guys so much for watching, and I'll see you guys in the next video.